I thank you very much for that question because it's a major reason is that for many years now, we did research together concerning brain tumors, especially gliomas. And you know that gliomas, beside meningiomas, are the most frequent brain tumors in humans. But in fact, gliomas are better researched than meningiomas up to date. And what have we done? We investigated together with quantitative microscopy, microbiology, and also radiological methods concerning spectroscopy and so on, and correlated this with the clinical outcome of the patients of the tumors. And then, of course, years later, the whole forms of programmed cell death appeared. Ferroptosis was investigated, Ferroptosis, and so on. And so we also investigated these forms of programmed cell death in oncology, especially gliomas. And therefore, we decided to leave the border of oncology, and we wanted to know what about these programmed cell death forms in other diseases, such as neurodegenerative diseases, Alzheimer, Parkinson, and also multiple sclerosis. And so for us, since we are interested in all these biological functions and what we can see in radiology or in the microscope, not just to investigate in tumors, but also in other diseases such as multiple sclerosis. So this is the reason why we came up from tumors now to multiple sclerosis. We do, and they will be very much focused on neuroradiology. As you know, I'm a neuropathologist, so I just can answer from the viewpoint of a neighboring discipline, which is neuropathology. But in our institute, we work close together. And please let me add that the head of our department, Professor Hatting, she's the main specialist for imaging, and also senior physician, Dr. Wenger. She does much research concerning types of MRI sequences and so on. So to answer your question, our plans are especially now neuroradiology studies, which start, of course, with the improvement of the MRI sequences itself. So we implement, for instance, quantitative susceptibility imaging, where it is possible to quantify the susceptibility in a single voxel and then construct the whole image. In other words, all that provides a better investigation of myelin and lesions in multiple sclerosis than other MRI sequences. And with that in mind, of course, we try to implement it in daily routine diagnosis together with laboratory findings, outcome of the patient. In other words, to see the alterations in multiple sclerosis better than in previously. And please let me add a final point. In multiple sclerosis, you know that the new McDonald criteria have appeared. It's hard to explain in a few words, but to come to the point, it provides an earlier diagnosis than in previous years due to several aspects which have been added. Kappa light chains in laboratory medicine, and in radiology, it is the central vein sign, a sign for inflammation, and the so-called paramagnetic rim lesions, which are typical for iron dysregulation. So to answer your question, these paramagnetic rim signs, they are the direct mirror of what we presented in our review, which is iron dysregulation, in which ferroptosis as a form of programmed cell death is one part. And we want to explore this in more detail and with a better recognition in new MRI sequences. So this is what we plan for the next future. Personally, I have a very positive relation with AI. First point, the term artificial intelligence is not new. It appeared, I think, in the late 60s and 70s of the last century. And in the 80s, when I did my doctoral thesis, we worked on quantitative histopathology, which means we quantified the size of cells. Then we did molecular analysis, epidemial growth factor receptor, and so on, and correlated this with other findings. And you know that during that time, the terms expert system appeared and also data mining. Of course, during that time, the capabilities of the computers were limited concerning data storage. So in other words, the term AI is not new for us. And nowadays, I would say, yes, AI can really support the physician in daily diagnostics, especially recognizing optic findings better than the human eye, which is, for instance, the so-called paramagnetic rim sign. This is a direct sign in multiple sclerosis for the iron dysregulation, and very specific, not 100% specific, but over 90%. So this is a very important sign. And to recognize this, I think artificial intelligence can support under two prerequisites. The focus of what AI has to do must be clearly defined. In this example, of course, paramagnetic rim signs recognition. And a second important point for me personally, the physician who is responsible for the patient must have the final word in decision making. AI can support and also suggests a diagnosis, but the final word must have the physician. And under these prerequisites, I think, yes, AI can be a valuable support in daily routine diagnosis.